A doorbell signals a visitor. A baby's cry needs attention. An alarm may warn of danger. But what ends when an important sound is not noticed? Salam and greetings. I'm Khairul Fawaz bin Kamal Rizalman from University Science Malaysia. This project presents an AI-powered acoustic event detection system designed to recognize attention-critical domestic sounds directly on an embedded platform using Edge AI. Important domestic sounds may be missed by deaf and hard-of-hearing users, older people living independently, parents, or anyone in another room or a noisy environment. A basic loudness sensor can detect that a sound occurred, but not whether it was a doorbell, baby cry, alarm, or background noise. Cloud-based classification may also add internet dependence and continuous audio transmission concerns. This creates a need for local, event-specific sound awareness. The implemented prototype uses a MAX9814 analog microphone connected to the ADC of the Renesas RA8P1 Titan board. Each cycle captures approximately 1 second of audio. CMS ISDSP extracts MFCC features, and a quantized INTA convolutional neural network runs through TensorFlow Lite for microcontrollers under RT thread. The model outputs one of 6 sound classes, the confidence score. During normal operation, inference runs locally on the board without continuous cloud audio streaming. Approximately 1 second of sound is captured as 16,000 samples. The waveform is divided into short overlapping frames and transformed into Mel-Frequency Cepstral Coefficients, or MFCCs. Delta and delta-delta features add time-based information, producing a 39 by 61 INTA feature map containing 2,379 values. The embedded CNN processes this map and produces one of 6 class outputs together with the confidence score. Acoustic event detection is not new by itself. To reduce mismatch between desktop audio and the deployed hardware, 106 1-second windows were recorded through the actual microphone and a DC path. The 102,214 parameter INT8 model is approximately 114.4 kilobytes and includes an unknown or background class to reduce forced classifications. The originality of this project is the complete TinyML sensing to classification pipeline running on a resource-constrained microcontroller. Next, we demonstrate the prototype in real time using 5 selected pre-recorded sound variants. We begin with 3 variations of baby crying, followed by 2 alarm and siren variations. The sound source, prototype, and inference output are kept visible together so that each result can be verified. The design combines one embedded controller, one analog microphone, and local inference, removing the need for an external computer or cloud inference subscription during operation. Based on the verified bill of materials, the core electronic cost is Rm289.90. This working prototype could be developed into a compact assistive smart home sound detector. Future versions may provide visual, smartphone, or wearable vibration alerts. These are future concepts, not current verified functions. Commercialization will require improved class reliability, user testing, compact product hardware, certification, verified pricing, and market validation. Thank you for watching.